And welcome to our online classes, and today we'll be solving numericals of chapter 4 energy. So we have the first question. We're going to solving the numericals of the chapter. I would request you to write all the formula on one page and keep referring them. So here we have the first question. A force of 30 Newton acts on a body and makes it through a distance of 5 meters in the direction of force. Calculate the work done by the force. So first we have to write given. You can write an answer here. Given, we have the force given is 30 Newton, which is in SI unit, no problem, checked. Okay, and the distance is 5 meters, again in SI unit, check. Now you don't have to write the word check or the tick mark. Just make sure whenever you write the given part, check whether it is in SI unit or not. Then, if it is not, you can convert it there as well. So we have to find work done. So let's go for solution. We can write work done is equal to force into displacement or distance. So we have 30 Newton into 5 meter. Not necessary you write the unit, but make sure you write it so it becomes easier. So it is 150 Newton meter, which is taken as 150 joules. So it's very important whenever you write the unit, write it in the SI unit. Okay, so work done is in joule. I hope you understood. Let's go for the second question. And the question number 2, a man lifts a mass of 20 kg to a height of 2.5 meter. Assuming that the force of gravity on 1 kg mass is 10 Newton, find the work done by the man. Now here you have to understand two important things. First, you have the given part. Okay. And we have mass is given to be 20 kg, which is in SI unit, no problem. The height is 2.5 meter. Please understand, the force of gravity on 1 kg mass is 10 Newton. This is another definition of G. Now, we understand that G is taken as 9.8 or sometimes 10 meter per second square. It is acceleration due to gravity. There's one more formula which says F equal to M into G. And in this case, you can take G as F upon M, which is Newton per kg. So that's how. So when you write this way, you write G equal to 10 Newton per kg formula. Okay. Not meter per second square. Although you write that, it is still okay. Okay, I hope you understood. So don't get confused over here. It's very important that you understand what it is given. Now let's go for the solution. So we are talking about assuming the force, find the work done by the man. So here the work done would be, of course, the work done is related to force into distance. So the force is, first you need to find the force. The force is M into G. So the mass is 20 kg and G is 10. So this becomes 200 Newton. And now the work done. So the person is actually lifting the object to a height. So basically the distance covered is 2.5 meter. So we have 200 into 2.5. So 25 into 20. So that is 500 joule. That's it. That's your answer. I hope you understood. The most important part was to understand the G value, why it is 10 Newton per kg and why the definition sometimes comes like this. Okay, let's go to the next question. Again, very interesting. Body when acted upon by a force 10 kg F moves to a distance of 0.5 meter in the direction of force. Find the work done by the force. Take 1 kg F equal to 10. Now, we understand that 1 kg is another unit for giving you force. But, so 1 kg F, sorry, first we write the given part. So we have the force is given to be 10 kgf. Now, this is not in SI unit. So you convert this. Now, 1 kgf is 10 Newton. So this will be 10 into 10 Newton. That is 100 Newton. Okay, assuming, so either given we have 1 kgf was 10 Newton. Okay, and the distance is basically 0.5 meters. So yeah, it is checked. It is in SI unit. So let's go for solution. Solution is very simple. Again, we are finding the work done. So work done is equal to force into distance. Now the force is in 100. This is in 0.5. If you multiply, you get 50 joule. That's it. So the work done by the force is 50 joule. Easy. And if you're not understanding or if you feel like I'm going fast, you can go back, slow down the time, increase the time if you want. But keep writing. So you can, in between, you can pause the video and keep writing the answers in your book as well. Two bodies, question 4. Two bodies of same masses are placed at height h and 2h. Compare the gravitational potential energy. Now, many students get confused over here. We are not exactly subtracting the gravitational potential energy. Comparing means we're dividing it. Okay. Unless they ask you increase or decrease, then you subtract. And if they say to compare, you divide. So two bodies of same masses are placed at height h and 2h. Okay. So we are given. So we can understand M1 is equal to M2 in this case, same masses. Okay. And H1 is equal to H, H2 is equal to 2H. Okay. I hope you understand G is same. Solution. So let's understand we have potential energy. Sorry. Potential energy, that is U1, is taken as mgh1 upon potential energy, that is U2, that is taken as mgh2. Now, since M and M are same, we have h upon 2h, hence it is 1:2. So that's it. That's your answer. So we have U1 is to U2 is equal to 1:2. I hope you got it. Now, if you don't understand anything, make sure you write it in the comment or you can message me directly. Okay, let's go for question number 5. Find the gravitational potential energy of 2.5 kg mass kept at a height 15 meters above the ground. The force of gravity on mass 1 kg is 10 Newton. Now we are finding about potential energy, so we will be writing mgh obviously. So we have an answer given. We have, let's write the given part. Make sure you write the given part. It is very important that you build up this particular method of doing in the book. Now we have mass is given to be 2.5 kg. Check. SI unit, no problem. At a height of 15 meter. Check. Meter, no problem. The force of gravity on mass 1 kg is 10 Newton. Again, it is given as G. So we have G is 10 Newton per kg. So right now, let's go for the solution. So we are asked to find the potential energy. So potential energy or U1 at that particular height is given as mgh. Put the value, we have 2.5 into 15 into 10. Okay, so we got 25 into 15. 25 into 10 is 250. 25 into 5 is 125. That is 375. So we got 375 joules. Yes, right. That's right. Okay, I hope you got it. You can actually multiply aram se, no problem. 25 into 15, you'll get the answer, same answer. Okay, take your time, but make sure you're not leaving it. Let's go to the next one. Question number 6. The gravitational potential energy stored in a box of weight 150 kgf is 1.5. Now, this is 10 raised to... Okay, let me just write it. Given. So first we'll write. So we're still asked to find the potential energy. Obviously, we'll be thinking about in mgh. Well, the weight of the body. The weight and mass are different. So weight is basically you're talking about the force of gravity, which is 150 kgf. But 1 kgf is not in standard unit, or you can say the SI unit. So we have to convert. We know that 1 kgf is 10 Newton. So we have 150 into 10, and that is 1500 Newton. Sorted. The gravitation and the potential energy is given. So we have the potential energy is given to be 1.5 into 10 raised to 4 joule. Find the height of the box. You have to find height. Well, let's go. Very easy solution. We already know the formula. Now, potential energy is equal to mgh. Now, the mass is not given, the G is not given, but we know that mg is actually the weight. So we have potential energy upon the weight is equal to h. So we have potential energy to be 1.5 into 10 raised to 4 upon 1500. So let's so 10 raised to 4 is 10,000. Multiply 10,000 with this, we have 1523. Okay, upon we have 1500. You can just cancel. This is 10. So the answer comes out to be 10 meter. That's your answer. The height of the box is 10 meter from the ground. I hope that was easy. Easy? Let's go ahead. The potential energy of a body of mass 0.5 kg increases by 100 joule when it is taken to a top of the tower from the ground. If the force of gravity on 1 kg, now remember, when it is from the ground, we are basically talking about a normal height. But if it is, let's say, from 4th floor to 5th floor or 4th floor to 10th floor, then there's an increase or change in potential energy. Okay. So first we have answer given. The potential energy of mass, okay, mass is given to be 0.5 kg. So check, no problem. Increases by 100 joule when it is taken to the top of a tower from the ground. Now, if it is from the ground, we are directly talking about potential energy, no problem. So that is 100 joule. Again, in SI unit, check. If the force of gravity on is 1 kg equal to 10 Newton, so that is G given to be 10 Newton per kg. What is the height of the tower? Okay, again the same question, but in a very interesting way. So we have potential energy is equal to mgh. Okay, potential energy given to be 100 joule. M is given to be 0.5. G is given to be 10. H is unknown. So we have 100 equal to 5. 0.5 into 10 is 5 into H. So we have H equal to 100 by 5, which is 20 meter. So the height of the tower is, you can write inverse, height of the tower is 20 meter. Quite interesting. Okay. Very easy. It's easy questions now. Question number 8. A body of mass 10 kg, 60 kg is moving with a speed of 50 meter per second. Please remember this is second inverse. Find its kinetic energy. So we have given, again, very easy. Now we are talking about kinetic energy. So we are moving from potential to kinetic energy. So we have given mass will be 60 kg and speed, we take speed in V, is 50 meter per second, or you can write 50 second inverse. Okay, generally I prefer this one. Quite easy to write, understand. Solution. So you have to find solution. Now remember, kinetic energy depends on mass and velocity only. So we have the formula kinetic energy to be half mv square. Put the value, we have half, m is 60, v square is 5 and 50 square. So make sure you do this. So we have half into 60, 50 square is 25 and 0, 0. Okay. So now we have to just cut. So this is 30 and we have 25 into 3 is 75. Take the 3 zeros. And that's the energy of the mass of the body moving with the speed 50 meter per second. Okay, I hope that is easy. This is the kinetic energy of the body. Let's go to the next one. A truck of mass 1,000 kg increases its speed from 36 km per hour to 72 km per hour. Find the increase in its kinetic energy. So now they have asked about increase. So let's write the given part. So whenever there's an increase, decrease, or compare, we have subscript 1 and 2. So let's understand the mass remains the same. 1,000, again, the SI unit is checked. It is in a kg, no problem. Speed. Now speed comes in 36 km per hour. Now kilometer per hour. Now should we compare this? Should we like change it to SI unit or no? Kilometer per hour can be written in SI unit as 1,000 upon 3600. You can cut this, and if you have, we have pi by 18. So this is written as 36 into 5 by 18 meter per second. So you don't have to remember it. You can directly do it. Okay, so we have 8 and this is 2. So this is 10 meter per second, whereas V2 is 72 kilometer per hour. So again, the same factor, 72 into 5 upon 18. Now we know that 18 fours is 36, 72, sorry. We have 4 pies are 20 meter per second. So we got our two values. Now let's do the solution. So solution. We got change, increase in kinetic energy of the truck is equal to half m. Make sure you write the bigger one first. M V2 square minus half m V1 square. So you have half. You can take m common. You take V2 square, that is 20 square minus 10 square. Okay, so we have half into 1000 into V2 is 420 square is 400. This is 100. So what we have right now is, I'm erasing this one. So we got half into 1000 into 300. And if you cut this one, we got 150, and that is 150,000. Or you can write 1.5, 12345 into 10 raised to 5 joule. Or you can write 15 into 10 raised to 4 joules. Depends on you. So that's it. That's the kinetic. That's the increase in kinetic energy of the truck if it changes from 10 meter per second to 20 meter per second. Okay. Let's go to the next one. Okay, a car is moving with a speed of 15 km per hour and another identical car is moving with a speed of 30 km per hour. Compare their kinetic energy. Now, when we compare, we basically cut the values. Okay, so let's say we have given velocity V1, you can write 15 km per hour. You can convert it. You can have, okay, since we are not, okay, please remember. Okay, let's go for question number 10. A car is moving with the speed of 15 km per hour. Another identical car is moving with the speed of 30 km per hour. Compare the kinetic energy. Now, in this case, you'll learn a very interesting concept. Whenever we compare, since we generally cut all the values and the unit by unit is the same, so what we get is a pure number ratio. So we don't have to convert this into SI units. Okay, and if you see, we have given 15 km per hour, 30 km per hour, which is not a factor of 18. So you can understand they have given it deliberately not divisible by 18. So let's understand, we have V1 is equal to 15 km per hour, although not in SI unit, we will keep it like this. V2 is 30 km per hour. So now we have to compare. So let's go for the solution. Since the mass is same, we can say M1 is equal to M2 is equal to M. So solution, we have comparing, we have kinetic energy 1 upon kinetic energy 2 is given as half M V1 square upon half M V2 square. Okay. This type of questions are very important and they can come in your MCQ type of questions. So we have 15 square upon 30 square. So in short, we have 15 by 30, the whole square. You can get 1 and 2. We have 1 by 4. Okay. So this is practically, you can make it a statement like this. If the speed goes double, the kinetic energy goes 4 times or quadruple. Okay. That's it. Let's go to the next one. And now we are entering into power. Okay. This is 10 raised to 5, by the way. So given a pump raises water by spending 4 into 10 raised to 5 joule of energy in 10 seconds. Find the power of the pump. Very, very easy. A very standard thing. So basically we are given energy, or you can say the work done is 4 into 10 raised to 5 joule. Now remember, whatever work you do, that will be the energy. So if you hear the word energy, you're basically talking about work done. And time taken is 10 seconds. Now this is in standard unit, this is in standard unit, so no problem. Solution. Okay, power is equal to work done upon time. Let's put, we have 4 into 10 raised to 5 upon 10. So you can just cut 110, this becomes 4, or you can convert it. So the answer is 4 into 10 raised to 4 watt. Please remember, and you don't have to write the word watt, just write capital W. Now here, this is work done, and this is the unit watt. So don't get confused over here. Also, this you could have solved like 4, 1, 2, 3, 4, 5. This is 10 raised to 5, and this is 10. You can just cancel like this. So your answer comes out to be either 40,000 watt or 4 into 10 raised to 4 watt. Sorted? Okay, I hope you understood. Let's go to the next one. It takes 20 seconds given. So I'll write a given part. It takes 20 seconds for a girl A to climb up the stairs while girl B takes 15 seconds for the same job. Compare the work done and the power spent by them. So first you have to compare the work done. Okay, so the work done remains the same so we can understand they are climbing the same thing. So the work done is equal to W2. Okay, because they're doing the same job. Doing the same job of climbing the stairs. Okay. Okay. And of course, the time one is taken to be 10 seconds. Girl A takes, you can say TA, 20 seconds. And TB, the girl B, takes 15 seconds. So solution, let's go for first part. We have solution. W1 by W2 remains 1 because they are doing the same job. The work done by them is same. Now the power is different. Power P1 by P2 would be W1 by T1, or you can say PA by P2. Oh, sorry. Okay, got it. So we have T1 is equal to 20 seconds and T2 is equal to 15 seconds. Let's go for the solution. Now the solution is very interesting. The first part, the work done, compare the work done. So we have W1 by W2 is equal to 1 since they are doing the same job. No problem. Okay, so 1:1 you can say, or just 1. B, power spent by them. So we have P1 by P2 would be W1 by T1 upon W2 by T2. So you can understand the denominator will go up. We have W1 by T1 into T2 by W2. Okay, and since W1 and W2 is same, so we have 15 by 20 comparisons. Okay, so we can have P1 by P2 is equal to 3 by 4. So that's the comparison between their powers. Okay. Exercise, I hope you liked it, and please visit and revisit it whenever you require. Make sure you save this particular link or video. And if you want to share it with your friends so that they should also understand, make sure you share it. Thank you.